Hello, everybody, and welcome. So I know you're all expecting Andy. It's been a while since I've done this, so I'm going to be a bit rusty, working my way around the controls. As you can see, we've got I'm going to say a motley crew in. As you can see, we've got Michael. How are you?
Hi there, Des. Fine, thank you. How are you?
I'm fine, thank you very much. We have Roger.
Good evening, everyone.
Yeah, our regular pirate. Then we've got John.
Good evening from soggy Essex.
Soggy Essex. That's lovely, isn't it? Right. So just wondering what the emblem is of Soggy Essex. And then we've got all the way from yeah, all the way from it's Wellies. It's all the way from across the pond. We have Lou. How are you, Lou?
I'm doing well. Still working on my proper British. So
you learned proper English now. You got full
in the autumn.
I got schedule down. I've got that part.
What schedule? Schedule.
Oh, that's for us. It's
And we've got Pete here. It's lovely to see Pete again. How are you, Pete?
Oh, I'm not too bad, thanks.
That's good. That's
Doing
good.
well.
You're just down the road from me, so I know what weather you're getting.
Same.
Yeah, it's exactly the same. Same puddles. So
Yeah.
yeah, it's lovely to see everyone. Unfortunately, Andy's MIA. He's missing in action. There's been lots of storms in this region, which has affected his servers. I think he usually serves through Madrid, but it's really gone slow, and he hasn't been able to log on. He did try even through Frankfurt. He's been traveling around all around Europe trying to find somewhere with a decent server, but unfortunately, he's been unable to resolve his issues. He was going to present an exoplanet presentation, which is in the title, but unfortunately, of course, with Andy not being here, that's going to be knocked on the head until next week. So we'll look forward to that next week. But we've still got a packed show. So without much ado, well, basically, I'll just do a little bit more of the old housekeeping. As I said, I've noticed that people, Ian, what we've got, Ian, Alan, Gerard, thank you for your kind donations in the chat. They were very much welcome. We've got our bills coming up soon, and every penny is really appreciated. And we'd like to continue. But yeah, it's absolutely fantastic. Thank you very much. You're also very, very generous. So thank you for that. Just a quick one. There are several ways you can either use well, I'm trying to find the cue card. As I said, I'm not used to this. First of all, we've got you can either buy merchandise. Let's put it this way. So if you I don't know whether we'll just see if this comes up on the chat. No, again, they still haven't resolved that. You can go to the. I'll leave the QR code up for a second if anybody wants to click on it. Take the QR code to the Space Oddities shop, where you'll find our merchandise. We've got T-shirts, hoodies. The T-shirts are 25 now, is it, Michael? Sorry, I'm so long.
I think they're 25. Yeah, the T-shirts
25. That includes postage and package.
Yeah,
And the hoodies are £40, isn't it now?
that's right. Yes. Yeah.
Yeah, £40, including postage and packaging.
Yeah.
Anything from abroad, please add an extra £10 for postage and packaging. They're very top. They're top quality. So if you wish to order anything from the shop, then please do so. As I said, we've got the hoodies. We've got the two styles. We've got the zip up the front with the design on the back, and we've got the overhead hoodies, which have the design on the front. And I'll tell you what, they're fantastic, absolutely fantastic. Again, we got the T-shirts. Just get rid of that second. Sorry. We got the T-shirts. We've got this is the this is the new T-shirt. This is the 2024 T-shirt. So that's our new one. But we've also got lapel t-shirts. That's with the old logo. So these are the retro ones. These are the ones going to be worth money in a few years' time. Yeah, or like I said, you can. This is one of the old designs. Now these are probably worth about £3,000 or £4,000 at auction now because they're absolutely fantastic. So we're still selling them for £25. But of course, if you put it in auction, you'll get thousands of pounds because it's retro. So, and also, if you another way you can support us again is if you would like to buy us a coffee. I'll leave that up there for you. So, anything that you can afford, just would be absolutely fantastic. So that's basically it for the minute. So, right, as I said, we've got a packed show. It's a shame that we won't have Andy's thing, but unfortunately, that's the way the cookie crumbles. So, first of all, Lou, you're going to give us the second part of your. Now, what was it again, John? I can't say global warming, can I?
Global climate change.
Global climate change. I was corrected. So you've got to get the right terminology these days.
Yeah. Oh, you have. Do you know,
Yeah.
I got into trouble when I was working on the BBC, and I interviewed a guy on global climate change,
Yeah.
and I got told off. The BBC told me I couldn't talk about it because there wasn't no concrete facts that it existed. The
Oh my
BBC, for crying out loud.
I thought that only happened in America.
Yeah.
Yeah.
Oh yeah, but that's it. I mean, it's not called the biased broadcasting company for anything.
No,
So,
not at all.
yeah. So okay.
Well,
So
Feeders have made me redundant.
yeah. May the fleas of 1,000 camels and all that in it. Right. Okay then, Lou. Over to you then, please.
Right. Can you bring up my
Yeah, I just
presentation?
coming over. As I said, I'm really an amateurish at this, so I haven't done it for so long, and it's been so good. So there we go. Okay then.
Considering none of us are getting paid, I guess we're all amateurs here. So
Yeah.
okay, so this is the second in I think a 3-part series on global climate change, and at least until this coming January, I'm pretty sure I can continue to call it that. Anyhow, so the first part we talked about the evidence for the data that I showed you the data of how CO2 rate mole fractions or composition of the atmosphere are increasing, and how the temperature in the atmosphere is increasing commensurate with the CO2 amounts. And we talked a little bit about why CO2. We talked about molecules with positive dipole moments, not diatomic molecules like O2, N2. Those don't absorb and emit in the infrared. So we kind of got that far. And what I need to do now is see if I can go to slide number 13, I think. Let's see if that's what I meant. Yeah, I think that works. Okay. So I want to tell you a little bit about the methods now that are used to get this exciting information that the planet is warming and we're all doomed. What are the methods that are used? As good global climate change ambassadors, right? You need to understand how this is done. You obviously are smart ambassadors. You don't just accept what I say blindly. Perhaps you shouldn't accept it at all. But here's the information on how this is all done. We can go back some hundreds of thousands of years pretty easily by looking at the gas bubbles in ice cores. Okay, and these trapped gas bubbles are remnants of the atmosphere at that time. Okay, and so by knowing where in the ice core we are, we know what time it was, and then we can measure the CO2 levels. We can even measure the isotopic ratios of things like oxygen 18 to oxygen 16, or carbon 13 to carbon 12. And that gives us an indication of what the CO2 content was, as well as the temperature. We are also interested in hydrogen ratios, D to H, which is the deuterium to hydrogen ratio, or deuterated water to what we might call regular water ratios in the ice cores. And these are good indicators of the temperature that formed in the snow at that time from that ice core. So we use mass spectrometers with these ice bubbles to pass the molecules through a magnetic field, and that these molecules, the direction of path is changed, and the angle that it's changed by is proportional to the mass of the molecule, and therefore we can find out what the molecule is. Okay, pretty straightforward stuff, right? So we can have direct measurements all the way back to about 1880, where we actually, somebody stood outside and measured the CO2 content of the atmosphere. We have a CO2 observatory at Mauna Loa in Hawaii, the Mauna Loa Observatory. And some of this data is from that. And we take that data directly. This gives us direct temperature measurements. You stand outside with a thermometer, and direct CO2 measurements. So these are direct measurements back to about 1880. We can do that. Oops. But we might like to go further, right? Let me get this off my screen here. Okay. Might like to go a few 100,000 years back, and that's what we were talking about, the ice cores and measuring the isotopic ratios of various gases, not only CO2, but methane and nitrous oxide, which play a lesser role in the temperature of the Earth. Even though they are both powerful greenhouse gases, their abundance is not that great. So we can measure somewhat indirectly the temperature and the carbon dioxide abundance in the atmosphere going back a few 100,000 years. What if we'd like to go back further than that? What if we'd like to go back 65 million years? Well, it can be done through proxy samples and proxy analysis. And this is done largely by looking at the carbon-12 to carbon-13 ratio in ocean and lake sediments. From that, we can reconstruct past atmospheric carbon dioxide levels as the relative abundance of these isotopes with marine organisms like plankton will vary depending on the amount of carbon dioxide present in the ocean or in the lake at that time of their life. So, and what the mechanism is that lower carbon-13 to carbon-12 ratios indicates higher CO2 concentrations in the past. And this is because when CO2 levels are high, these organisms, plankton and other organisms, they preferentially, I guess, take up the lighter carbon-12 isotope. And that leads to a depletion of carbon-13 in their shells or in their organic matter, and that gets preserved in the sediment. So these are proxy observations, if you will, a little bit less reliable than the isotopic ratios of air bubbles in the ice cores, but still fairly good indicators of the CO2 levels and the temperatures that go back as much as 65 million years. This final slide that I have for today is indication of, again, just the CO2 amounts and on the bottom graph, and the surface temperature in the top graph. And what you're seeing here are various data points taken from various kinds of animal and plant species from these from these ocean and lake sediments going all the way back to almost 70 million years ago. And so this is the actual data, and you can see where the data actually supports each other, right? We can get these carbon-12, carbon-13 ratios from various kinds of life that are kind of frozen in time in the sediments, because once they die, they stop breathing and exchanging energy with the ocean and with the atmosphere, and so that freezes their carbon-12, carbon-13 ratio at that time. So this is how we get, this is how we know about global climate change over the past few hundred years, over the past few 100,000 years, and over the past tens of millions of years on our planet. So there's the data, and that's how we make the measurements. And next week, if all goes well, I will be talking about, okay, there it is. There's the information. What's the impact to life on Earth? And then later we'll be talking about what can we do about it. So that's it for today.
Oh, thanks for that, Lou. That was really interesting. I was surprised. I think it was the second slide you showed where they were looking at atmospheric temperatures. You know, you say somebody out there waving a thermostat. How literally they, yeah, the second one, that's it. How literally they followed each other. They were almost exactly the same. So there was very little variation at all. There was a bit of variation at the beginning of the century, but yeah, that's very interesting that they literally mirror each other all the way up. So yeah, very interesting.
It is a strong indication that the global climate change that we're experiencing now predominantly is human caused, from deforestation, from fossil fuel burning, and other sources. Yeah.
Of course, when you were talking about ice cores, tree rings, and things like that, they are such. Well, they're basically the history section of the library of the Earth, because they can tell us so much. They're used as well for detecting what's happened in the past as regards space weather and things like that. How, you know, different, because we know the cycles, we know the sunspot cycles every 11 years, and we can trace them all the way back in the cores and the tree rings. So yeah, they're a great analytic tool. So yeah, anybody else got any questions for him, John?
Yeah, I've just got, you know, it's a biology one. Why would organisms take in carbon-12 preferentially to carbon-13? It's more of
and that only happens when the carbon CO2 abundance is high. And I don't know the answer to that. That's a good question.
Yeah, because it's mostly based on the movement of electrons. You know, it's the biology's separating out ions and atoms and what have you. So the extra neutron in the nucleus, in theory, shouldn't make any difference unless it's what's the word I'm after? A boundary osmosis process.
You can be assured that it's a more efficient process.
Yeah.
For some reason, it is more efficient. So that's a good question. I'll have to look that up. I was thinking as you're talking about tree rings, Daz, that my aunt Eloise just passed away recently, and she was from San Francisco. And we would have these little kind of mini debates about which was better, East Coast or West Coast, US. And one of the things I'd say is, oh, we have all these old things on the East Coast, you know, back to the Revolutionary War. And she'd say, oh, that's nothing. We have redwood trees that are thousands of years old. And so I've been to the Muir Woods and the redwood forests, and these trees are absolutely massive. And of course, some of them have died, and you can see the tree rings in them.
Yeah, and they span over thousands of years, as you say. So yeah, it's very, very good indicators
Can you guys
of climate
hear me?
change. Yes, Aaron. Hi, Aaron.
Oh, well, Hi, I'm here
It's the ghost
audio,
of
but
Aaron.
I can't get here video. So I think I have an answer to your carbon-14 question. So my understanding of how they
Carbon 13.
analyze carbon-14, 13, not 14?
This is the ratio of 12, carbon 12 to carbon 13. But carbon 14
14.
dating can be done in
Yes,
tree
okay,
rings.
that's.
And,
I'm sorry, misheard. Never mind. I'm off on a different planet, obviously.
it's okay.
What's it like up there?
Sunny.
Okay, and of course, anybody in the chat, if you've got any questions for Lou or for any of us, pop them in the chat and we will endeavour to answer them. Don't ask for lottery numbers, because if we knew them, we'd be keeping them to ourselves. So yeah, well, thanks for that, Lou. That's great. Look forward to next week actually, and seeing what. And of course, as we said, we spent a lot of time and money now putting lots of Earth monitoring satellites up, and we're putting more and more up, looking at different systems, biological, weather, and everything else. So it hopefully we'll be able to find out. Well, we know what's causing it. We see if we can actually turn something around and do something about it. So thanks for that again, Lou.
Yep.
Right. I think next up we will have Mr. Roger with his What's Up in the Sky.
Wait,
And
Mr. Roger.
apparently we got a bit of a bumper gallery, haven't we, Rog?
Well, all these people putting in after last week's plea obviously worked. So
Yeah,
yeah, we've
fantastic.
got a very, very good amount of images, although there are a few repetitive themes.
That's no problem.
But that doesn't matter, because everyone puts in their own images, and we will see.
We will show them. We will show them. Okay, and I'll just put you on them, Rog.
Okay. Right, here we go. So we're coming up to the end of September. Oh dear. So we're currently experiencing the last quarter moon tonight and heading towards a new moon. And this was what it was like a few nights ago, when there was a brief spell of clear sky. Shock horror. That was a bit of amazement. I nearly fell over in shock at seeing a bit of clear sky, but that's how it is at the moment. So we're still got the summer triangle still up in the night sky, and obviously that is now fading away now, but we are dominated by Andromeda and the square of Pegasus, and looking over towards the east we'll see Saturn. We see Saturn, and not long after we'll be seeing Jupiter and Mars. But we've also got Uranus available as well. So we've got Uranus in Taurus and also Jupiter, but we've also got Mars, which is transversing through Cancer. So things are all looking quite well at the moment. So still a few objects there to see. And obviously, just before sunset, Mercury is getting very close to the sun from our viewpoint, and Venus quite low down, so two very difficult targets to see, although Venus being a bit further away is still just about visible, although it isn't far above the horizon than we have for the sun. So as you can see through the week, Mercury is just passing around the sun there, so it will become impossible to see. We have got Titan, if you're interested in looking at Saturn. It's currently north of Saturn on the 25th, so that is tomorrow, should there be any opportunity. And on the 30th, 5 days later, we've got a transit of Rhea across the surface of Saturn, and that's all thanks to the very thin inclination of the rings. Without them being that thin, we wouldn't be able to see these opportunities. So that's worked out quite well. So be aware of that. There are some images of Comet Sunshine Atlas at the moment, but obviously with it being at perihelion on Friday, which will be 37.2 million miles from the sun, we're going to be a bit difficult to see. So I've marked this out for the middle of next month, when it will start to become visible in the evening skies. Obviously, it will be a lot easier when the clocks go back from the 27th of October. But that is getting to be quite an interesting object. It's got a bit of a tail on there, so will be an opportunity to see that in about a month's time. So be aware. Okay, we do have some images from the James Webb. This is ARP 107. And this is just showing you what can happen when you've got a supermassive black hole in the center of a galaxy. And looking at this, you can see the arms being swirled around to the core there, and just gives you an idea of what mighty powers that they are. And this version gives you an idea of all the new stars that are forming around the outside of the galaxy, and gives you an amazing amount of detail there to show you how much creation is on the go, despite that supermassive black hole swirling in all that dust. So quite an awesome thing to see. Okay, so here we go with our large gallery for this week. Thank you to all those that put anything in. I'll get mine out of the way first. So I've been trying to do the Wizard Nebula. I've only got this as a HOO image. I'm just waiting for some sulfur details to come in, but that's dependent on what we have with the clear sky. So this is what my Wizard interpretation in HOO is looking like.
Wow.
Wow.
That's really nice.
Yeah.
That is a wizard of a photo.
Yeah. I could never really see the wizard in that really very well, but there we go.
Oh, right.
Anyway, so when I've got the sulfur details, that will become a bit more colourful, shall we say. And here's my twist on last week's partial lunar eclipse. That's what.
Oh yeah.
This was a little while before the complete 8% coverage that we got, because as usual, clear skies up to about 10 minutes or so before, and then it was complete cloud cover, and that was it. I was doomed.
I like the contrast of that, Roger.
But yeah, I did enhance this picture afterwards, obviously, to get the details of the moon, but it gives you an idea of just how much little there was of the moon that was actually in the complete shadow of the Earth. But at least it became visible. It did look quite interesting when you looked at it visually. It did look a little bit odd, with a little bit of a partial piece come out of it, which shouldn't have looked like that if it was a normal phase of the moon. But there we go. Anyhow, right, and here's a picture from Michael, which he took on his iPhone, and the moon rising through the trees. And very nice.
That was just
Very
before
nice.
the Astronomical Society meeting as well.
Oh, right.
Very
So
fitting.
it's just, so it doesn't have to be done with a telescope or anything like that. Even phone images are very good, because they produce very interesting pictures.
Don't usually get nice pictures from iPhones, so that's really great.
Oh,
And
iPhone's really good for pictures now.
I know. And here's another one from Michael of the moon, which he took with his mirrorless Nikon Z7.
Yep, that's mine.
Oh,
So that was taken just a few hours before the partial eclipse started.
Yeah, very heavily cropped, I might add. Photographers amongst you would know that even with a focal length of 300 millimeters, the moon is still very tiny. It takes up a very, very tiny area of the frame. So
it's still very good. Still very good.
Yeah, so it's if you like, it's a digital zoom to get it that big.
mhm.
That's right.
Yeah.
But you did all right. Right, now we've got one from Gerard, and he's taken the picture of the moon with his sea star.
Oh,
Oh,
Ooh,
Well, that's quite nice.
Hmm.
that's coming quite well. Got some nice coloration on there. Bit of mineral colours on there, I can see.
Nice
Very
contrast.
good. Yes, very good. Well done, Gerard. And we've got a new person, Marco Sullivan,
oh,
and he
Oh,
was
hello, Mark.
using, and he's taken a picture of the North America Nebula from his Cheshire Garden, which is a Bortle 5 with a Astro camera, an ASI 533, which is what I use, but he's paired it with a Canon 100 to 400,
right.
and he's just got it tuned to 200 millimeters focal length. So this is roughly 2 hours and 19 minutes altogether, and he's put it on a EQM mount. So he's been learning about it, but he hasn't had enough practice due to the bad weather. Haven't we all known that? And this is his image. Look at that.
oh, look at that.
Oh, that's
Mm.
lovely.
That is gorgeous.
See?
Nice.
Oh,
Nice bit
So
of pelican
he's-
on the right.
Yeah, a little bit of pelican. Yeah.
oh yes, that's true.
Mm. He's
I
done
always
all right
think
there.
that's more of a pterodactyl than a pelican, but never mind.
Yeah, well, just interpretation.
hmm
Hmm. If you'd come up with that name first, then it might have stuck. Otherwise, it was the pelican, I'm afraid.
It's easier to say.
I'm quite impressed with that. So we've got one from John, and this is what he's done with his telescope and a 269, and I think it'll be self-explanatory what this is.
Oh,
Andromeda.
Oh, man.
Lots and lots of coloured stars there, and you can see the dark lane dust there through that image as well. Very good. Well done, John.
Yeah.
And on we go. And one from Ian. Now, Ian, I think, obviously had a go after what was talked about last week
Mhm.
of producing images from the JunoCam. And he says, I need help, I think, and not just generally. And he's been trying to process all the swirls on the surface there.
Yeah.
Mhm.
So the North Pole, isn't it?
Oh, interesting.
Not sure. Anyway,
Hmm.
we'll all have a go at that at some point, but
Yeah. Nice atmospheric dynamics there.
yeah. Mhm.
That's lovely.
Yeah,
Well
Pete's
done,
been
Ian.
doing some of that. So very good. And we've got one from Sonia, who's also got the partial eclipse done with her Google phone and her 10-inch dob.
oh,
That's nice.
Oh,
mm.
that's super nice.
Yeah, she's had this published on the BBC
Yes.
regarding the event of the night before. So I'm sure she's very pleased with that.
It was
Mhm.
on the BBC News wallpaper behind the news readers.
Yep. Okay. And our another regular from Jerry, also of the Andromeda Galaxy, with his usual Esprit and 2600 MC Pro. And we've got this.
Ooh.
Oh,
that's-
that's lovely.
Really
Look at all the, you've really got the detail of all the dust in that one,
Yeah, certainly have.
swirling around and going into the core there. Very interesting. There we go. Right.
nice definition.
Onwards and upwards, and one from Kevin. I think he must have bought something at the International Astronomy Show because he's trying out his new AM5N mount. Although this was only 50 minutes of integration due to the weather, I think. But anyway, this is what the elephant's trunk looks like with 50 minutes integration.
Oh, blimey.
Ooh,
That's pretty
blimey.
nice.
That is very nice.
What size telescope was that again? What,
That was his 100 Esprit.
100, 4-inch. Okay,
Absolutely.
lovely.
Very good. And there we
Very
go.
nice.
So right, okay. Here's a late admittance from me. I just reprocessed it. I don't know whether you might have seen this already before, but I've redone the Milky Way over the Stonehenge with my little APS-C camera.
Oh, yes, I saw that today.
Oh,
That was lovely.
that's really nice.
Look how dense that star field is. It's amazing.
Yeah.
That's very nice phone wallpaper.
Yeah, could be.
Yeah.
How long a integration time is that, Roger?
That's one frame, 20 seconds exposure at 1600 ISO with a 12mm APS-C camera, which is equivalent to an 18mm full frame at f2.
Wow.
So
I've done a lot of twiddling and tweaking on that, but that's only one frame.
wow.
That is
I guess you
lovely.
can't do.
Yeah, well, you can do, but obviously with the Earth's rotation, each frame will be slightly moved over,
Yeah,
even after 20 seconds. So it gets a bit fiddly, but I've worked out how to do it with just one frame.
that's really nice.
Okay, that's right, yeah. Is that the teapot at the bottom, just above the Stonehenge? Is that what it's called?
Just about,
Yeah, you can
about
just
got
yeah.
there, yeah. Yeah, it's just about gone now, really. By the time it gets dark, it's all sunk down too much now.
Yeah.
So basically, its season is over for the Milky Way, really, if you want to
Yeah.
keep the core in the field of view. So there we go. But that concludes our gallery bonanza that we had this week.
Excellent. Thank you for that. And thank you, everybody, for sending their
Yeah.
entrances.
Keep up the numbers. Keep up the
Yeah.
numbers.
That's what we like to see. So, yeah, lovely, jubbly. I hope nobody noticed that I totally disappeared. I completely lost contact, connection. So, but I noticed it was still running on the YouTube. So, yeah, I don't think anybody's missed anything. But I was struggling to get back on. We're having one of those nights again,
Yes.
by the looks of it. So, yeah.
Desmond,
Sorry.
I was trying to respond to Ian, who had a question in the text. And I think I typed too much, and it wouldn't accept the entirety of what I said. So maybe I could just answer it quickly now. Ian asked, given the data that I showed on global climate change, doesn't that say that it's just cyclic and kind of just generally happens? And the answer is yes, it does. It does generally happen over periods of thousands, hundreds of thousands, millions of years. We see that very clearly. And it's driven largely by Milankovitch cycles that we talked about 2 weeks ago, and also by changes in the continents as they drift and ocean current patterns change and things like that. So yes, that's true, but, and this is important, those changes happen over time periods of tens of thousands of years. The changes that we're seeing now in temperature are happening over tens of years, 100 years, 150 years. When the Earth changes, when the temperature of the oceans and of the atmosphere changes that rapidly over just periods of a number of decades instead of tens of thousands of years, species don't have a chance to adapt. And so we are seeing the sixth, as it were, mass extinction right now as a result of this rapidly changing temperature. So Ian, you're correct, but the time frame is different now. So that's the problem. Okay, thanks for letting me. I just want to make sure to get that in.
Yeah, because when you see any sort of like diagram or of a graph of the temperature, there is a sort of like a distinct kick up almost from the 1800s, and it's been climbing ever since. And of course, the 1800s, at the end of the 1700s and the 1800s is the start of the Industrial Revolution. So yeah, it started slowly, but it soon picked up. But yeah, like I said, it's a subject that really needs serious looking at. Needs some real serious research. People have got to start bickering and start pulling together, and let's get this thing sorted. It's like everything. Forget the geopolitics and everything. I mean, this because one of the solutions was that you could buy carbon tokens, or you could sell carbon tokens to different people, and they would take on your carbon thing. And I just don't understand it. You know, we've got to reduce. Well, it's not just carbon; it's other things as well. And we're going through our what can I say? Our supplies of everything, all elements, and all that, quite a rate of knots. So we've got to start really seriously thinking about sorting something out. But I mean, recycling is a good idea, but it's not everything. So
Ian says he asks because this is the argument he hears all the time, and that's true. That is one of the rallying cries of climate change deniers, and the answer is nowhere in the last 65 million years do we see temperatures changing as nearly as rapidly as they are now.
Yeah, it's the speed of change, isn't it, rather than the actual variations of the temperatures. Yes, they have varied throughout history, and when we know that, as you've just said, Lou. So yeah, it's the speed of how things are ramping up. They're getting faster. So yeah, thanks for that, Ian. That's a great question. Great question. Any more questions, anybody? Or okay. Right. I think it's now we're going to John.
Yes.
I think you're going to reattempt to do your processing.
I'm going to give it a jolly good go.
Right. Okay. And have you got anything to share? Because I can't see anything.
No, it's all right. I've just done that. Let me do that and that and that. Right. You should now be able to see AstroSurface because it says stop sharing at the bottom. It's not showing on YouTube just yet.
No, we've got nothing here, John. Are you using the this share screen button at the bottom?
Yeah.
The one with the little tally with the arrow at the top.
Yeah.
Daz, I'm going to try something. Oh, hang on. No, it's gone now. I was going to try something. Sorry.
Right, hang on. Did it with window. Oh, hang on. Nearly.
Mm-hmm. Well, if we all talk amongst ourselves, who can juggle? Got a pack of cards, anyone? We'll have a virtual game of poker. So we'll just see if John can get this up and running, because I'll have to do the same, unfortunately, because my presentation disappeared when I dropped out. But so where have we got to, John? All right, share screen.
It says I'm sharing
right,
here.
here we go. Here we go. Here we go. There we go.
Is that up then?
Yeah. We need to, I think, probably expand it, do we, or is that the whole slide?
That's just the header page. It's not showing on YouTube yet.
No, it is. We got quite a bit of a lag on there, so it will come up.
Oh right, okay.
Yeah, we've got AstroSurface, and of course, I think Ian.
There we go. Yep, there you go.
Yeah. I think Ian was asking
so
for some questions on this as well. So
right, yeah, okay. So what I'm going to do, I'm going to open first of all one of the files. Now, when you download this, and Ian have already seen this, you're given 3 or 4 different versions of the same image. 3 of them are the red, blue, and green filters. And then there's one that's called Map Projected, which is the full color version of all the red, blue, and green glued together already. And there's the raw data. So what I'm going to do, I'm just going to open the Map Projected one to start off with, and that'll just bring that up. That's the raw data. Now, what we found out last week is that Registax, which is a lot easier to drive than AstroSurface, is such an old program that for some reason Windows now doesn't see it as a screen to share. It's just, for whatever reason it is, it just won't share. So there's the start of that. Now, what I've done is, because Registax has got a neat little thing which AstroSurface hasn't, which is an RGB balance, an auto balance. So what I've done, I've already auto balanced it to get the right information up, and there we go. I'll just bring that up. It probably doesn't look a lot different yet, but you'll see what it is when I do the next image. So here we are. There's the little drive system of AstroSurface. First thing that we're going to do is we're going to do a little bit of play with the wavelets, which is pretty much all that Registack does. I'm just going to reset all these buttons down here. Let's put that back down to 0. Yes, I know. Right. So when you call up one of these windows, the first things it wants you to do is set a region of interest. So I'm just going to draw a little box there. It doesn't matter how big your box is at all, because it'll apply this to all of your things, all of the screen. So what I'm going to do, I'm just going to add a little bit of noise correction in there to start off with. Best thing to do. It doesn't matter how much you put in there, just a little bit. It just keeps it going. I can increase the gain a little bit just to increase the brightness of what we're looking at. And then I'm going to start playing with the wavelets. And you just, and again, it's just a taste thing. You just drag them around. As you see there, if I drag this one up and down, you can see.
Sorry, John, none of your what you're clicking on is actually showing.
Oh, that's strange.
We can see it changing on the picture that you've put up, but there's no actual controls showing.
Again, this is another issue with multi-screens, you see, because it's opened up the wavelet box as a separate little screen that I can drag around. I wonder if just a second, if I do that, let's do that. Oh, I've gone back.
You've got rid of it now.
Yeah.
It's gone.
Right. Is the little window there now?
No, there's no window there.
I can't do. I'm afraid that's what it is at the moment. See, that's what it's. Registax would just do it all automatically for you, but I can't show you the little window because it's a separate window almost, and it won't share it at the side. I can't see it to share it, which is a bit of a shame.
Yeah. So
so I can just do a bit of that, and then you click on do all, and then suddenly it gets a bit better, a bit stronger. I think a little bit stronger. Come on. There you go, and it just brings it up. I'm happy with that. I'm going to now just going to do a little bit of tiny bit of saturation, add a little bit of noise clearance. Yes, I know I've got to do that. Let's do that. A little bit of noise, increase the saturation a wee bit, do all, and just do it in tiny little steps because you can always go back. So just increase the saturation a bit. You click the do all button, and I think that's getting there. And we then want a little bit of local contrast, and there you go. You can do various things when you click the little local contrast button, which is up at the top. I'm just going to do local contrast, just increase that a wee bit. There you go. And that's pretty much it for the picture of Jupiter. And you just brought out, it's possibly a little over processed, but if you're doing this to submit to the JunoCam people, they don't really mind. It's just the fact someone's had a go, and it might bring out just that little bit of detail that they've not seen. And you can flick through in the color image the various filters there. So that's that one.
Kevin, sorry, John. Kevin's just said if you reduce the main window, you should be able to show them side by side. No, it's just no,
right.
Just
Okay, let's give that a go. Yeah, I can see my little mouse there. Let's just try bringing that one up.
No, we're not.
No, it's not. It's not there. You can see. No, unfortunately, it doesn't. No, it's worth a shot. It's really confusing. That is because I can see two mouse cursors now. Right. Anyway, the second one I'm going to do is slightly different image, but you'll get the idea of the auto balance. So I can't work out whether this one's Callisto or Europa. I can't quite work out the actual image. So this is the raw mapped projection kind of thing. But if you whack that through Registacks and do the auto balance, that's what you get. So it's gone white, which is what we're after. So again, if I just reset the wavelets in there, drag that down. Yeah, I know. It's just flashed up a little warning. Drag that down. Yeah, I know. I'm just going to draw my little box there. Increase the noise pre-filter a little bit. Tiny bit of deconvolution. Come on, Wiener deconvolution. And then I'm going to increase the wavelets, which is what's going to give us some... Ooh, too much. And the low frequency wavelets up a bit more. Too much. And then you click do all. And all this extra information just sort of starts popping out at you. And that's probably a little bit too much on that one. And so you just have to just tone it back a little bit to taste. And that's all it is, just to taste. There we go. That's okay there. We'll clean the color up a bit. You can reduce color noise in a little button. Yes. Reduces the noise a little bit. Local contrast is the other thing that I wanted to do. Up that a little bit. Okay, that, and there you go. That's pretty much. It might be a little bit strong, but it does bring out an awful lot of detail. Let's just drop those wavelets down a little bit, actually, because they're a little bit strong.
When you say you're dropping the wavelets or increasing the wavelets, what does that mean?
What it's a little. Hang on, let's reset that. When you're doing this, wavelets are a way of bringing out detail at different levels and different sizes. So you can fine tune different scales of the image. So the wavelet, a low level wavelet is going to enhance a small size, by the pixel size, and then larger wavelets higher up will allow you to play with slightly different levels and size. I'm just having a look now. Let's just reset that. Having a look now at just the sharpen feature, which is just same as doing sharpening in what's the word I'm after, in Photoshop or something. And you can get rid of some coarse noise in there. Clean the color noise. Increase a bit of sharpening. Too much again. Do all. And eventually, when it thinks about it, we're okay. So again, that's one of the reasons I do like doing the moons, because there's always something different might show up rather than just a little storm, which I think is not too bad actually.
Yeah, certainly different from what we started with.
It certainly is. Yeah, hang on, let's just show you what we started with again. Yeah, that's what you started with, and we went back to the previous one.
Oh, excellent.
Kind of thing. Yeah, it's a shame you couldn't see the boxes, though, the little extra boxes, just to see what was going on. I couldn't find a way of sharing them.
Yeah, that is weird, but yeah, I think with everyone's. I mean, Ian would know what boxes you were playing with, because obviously he's got it. So yeah, that's very interesting and very quick as well. I suppose the more you do it, the faster.
Yeah. The one thing on the JunoCam images to be aware of: if you're used to doing planetary imaging yourself, you'll have a much bigger bit depth and a lot more scope to sharpen the images up, whereas these are just PNGs rather than SIRS files that you can process up. So there's not a lot of strength. You can very easily, especially in Registacks, over sharpen these, and it starts to make them look a real mess. But if you just do it to taste.
Oh, great, that's fantastic. Right, is that it then, John? Yeah,
That's
thank you very much.
then.
For
Yep.
that.
Yep.
Yeah. Yes. Sorry, nobody could see the controls.
Yeah, it's a bit of a.
But yeah, there's very strange, because if you should see them on your screen, we should be able to see them as well if you're sharing your screen. But these things have got a habit of happening, or they've may have put in some sort of filter that you want to stop you from doing this sort of thing. I don't know. I don't know. They're cunning. They are cunning. But yeah, thanks for that, John.
That's all right.
If anyone's got any questions for John, please pop them in the chat. If not, then we'll just we'll move on. If you pop the questions in, while I'll do me sun thing. So you'll all be getting your cocoa and Horlicks earlier this week. So again, it was such a shame that we couldn't get Andy on because he had a fantastic talk all lined up. But we'll be doing that next week, and hopefully we will be. Well, everything will run smoothly. It would be nice for us. The last few weeks has been absolutely diabolical. Everything seems to be against us, but we're brave. We haven't burst into tears yet. Well, not on screen anyway. So yeah, okay then. Right. So I think everyone else has been. Has anyone else got anything to present or say, or have seen anything in the news that they'd like to bring forward? Nope. Okay then. So right, if you bear with me, I will now try to share mine. As I said, I had to. Right, here we go. Can we see two moons? Too soon. Two moons. Oh, I'm so tired. Two suns.
Yes.
Can we see those? Can we? No, not yet.
Yeah.
Yes.
Yeah, you can. Right. Okay.
Yeah, my two sons are upstairs.
Boom, boom.
Boom, boom.
Oh no, I didn't want that. No.
Oh,
back.
spoiler alert.
Oh, yeah, spoiler alert. Well, to be quite honest, this isn't going to take long. Because the sun's been very boring this week compared to what we've had over the last few weeks. It's really quietened down. We've had lots of we've shown lots of promise with things like 3825, 3827, and 3828 come around because they were firing off on the eastern limb. And like I'm looking at the left hand side, the 17th of September. And they were showing lots of promise. They were showing off on their far side, just over the limb. Then they come onto the face of the sun, and they've literally. And really, this week, I mean, to give you an idea, usually when I talk about how many flares have been registered, I'm usually talking about 100 to 130. This week, we've only had 42 flares, and most of them were C-class flares. So it's been, like I said, very, very quiet. We started the week with 6 active regions, and we've just literally, as you can see on the right hand side, which is today, we've actually got 7. But I have noticed that there's one that they've circled, but they haven't numbered it. I suppose they're waiting to see if it's to develop. Or it could be one that's actually just beginning to show. So we'll see what actually happens with that one. Right, as I said, it's been very, very boring. So I haven't produced the usual video where I show all the wavelengths. So what we'll do is I'll just show you the one I did do. And this is the blue sun. So here we are. And this is in 131 Armstrongs. And look at it. It's just sat there. We've got all this magnetic action going on the surface. And if you watch it, it actually dulls quite a bit. And it won't be until, if you look at the bottom, watch the date, until the 22nd that we get our one and only bit of excitement. You can see there are things firing off, but they're nothing compared to what we've been seeing for weeks. So it's passing off. There's not even much coming off on the eastern limb, although we're beginning to show it now. So here it comes. We watch this bright spot that's just gone, and bang, that was it. That was 20 things, and that was a M-class flare, and it's actually thrown some. It was quite energetic. It's actually thrown some material towards us, and we hope we'll probably be catching that very, very soon. It was. I'm trying to find it. It was an M. I think it was a 3.5, if I remember right. 3.8. It was an M3.8 flare. And what we'll do is we'll move on to the next one. Now, as I said, this week has been so boring, and I'll show you for why. This was last week. Remember this last week, and we had all this action going on throughout the week, and we even went up to a G4 there. So if we go back, and then if I look at to show you this week's, there you are. That you can see where the G4 was. It's dropped down, and we've been lucky at the beginning of the week to actually hit a couple of G1 storms. But the rest of the week it's been so quiet that there's been nothing really to talk about. Probably a little bit of action up in the Arctic Circle, but that's about it. We haven't even had the high solar winds from coronal holes to actually entertain us as well. So that shows you how boring it's been. But as I said, we did have on the 22nd that thing, and here we are. This is in two different wavelengths, and you can see that was the. It was moving. It's moving quite fast. That was the CME with the flare. As I said, it was a 3.8, and that has been analysed to actually show us. I'll show them, play them again. That has been analysed that it's actually going to hit us not tomorrow night. It's the I will show you when it's going to hit us, but it's a beautiful flare. I'll just play it one more time for you so you can see it. Oh, here we go. I'm going on to the cactus. So here is the cactus image, and what I'll do is I'll just quickly play this for you, and you'll see it just fire off. Oh, that ain't going to work either, is it? No. It's missing one frame. There is a big expulsion. See if I can pick it up. There it goes. You can see it there. So if I play it from about here, we should be able to get it. Boom! There it goes. And that's and a big chunk of that is coming towards us. So I will just show that this is the Met Office, the UK Met Office, and as you can see, we're due to get a bit of a hit, possibly around the 26th, with the night of the 25th and the 26th. You can see this little green bump at the top here. Remember, at the top we're looking at plasma density. So basically, that's the sort of like how the plasma count, the solar energetic particles. So we're looking here. We're looking down on the north pole of the sun. So this is being projected out towards the Earth, which is the green dot just here. And what we're looking at here, we're looking through the sun this time, east to west. So we're going to get a completely different version. I'll run it again for you. There we go. So if you watch these, you can actually see there goes the bump, and you can see it pushes out and it catches us in the top. Just literally on, it's a side swipe. But as we've said before, there isn't much in the way of high winds to go with it. We do have one coronal hole, but it's a small one up towards the North Pole. So yes, keep an ear out for tomorrow night. Looks around about just before midnight, because as we said, we've seen this before where everything looks as though it's going to be low, but then next thing we know, we've got G4s, G3s, G4s firing off, and they could produce aurora somewhere in the UK. So let's hope the weather's decent. So, and if
Now,
anybody does get any
these are model, these beautiful animations that you have here. these are models that are
Yeah.
built, right?
Predictions, yeah.
Based on data, but they
yeah.
are models. Okay.
Yeah, that's it. They're not it's not written in stone. But this is the data that they're using. They're projecting what they think is going to happen. But that could all change. Because without the high winds that we've been experiencing, solar winds from the sun, there's been nothing to clear the path for this to move fast. And all the little tiny flares we've had have all just been moving along slowly. There's nothing to buffer them up together and to push the winds even faster. So if this CME does catch up, we would have a big whoomp on it. So it's just keep an ear out for your warnings, and maybe, just maybe, we might get something, but I don't hold out much hope for this one. But then again, I said that last week, and I got it completely wrong. So let's see what else we've got. This is what we've got on the sun at the moment. We've only got 2 in the red with a mixed magnetic complexity. They're the ones that are usually going to give us the bigger flares. But any of these could actually fire off at any time. But usually the more complexity you've got in these, the red ones, the more chance that you're actually going to get an M-class flare, or maybe even an X-class flare. But yeah, everything's really quiet at the moment. So what are we expecting to come around next week? Well, we've got 2 big spots coming round. We've got 3806 and 3808 that looks as though they're virtually in one big lump. So they could be exciting. And then that is closely followed by 3811. So we'll basically see what they bring. This 3806 should be appearing on the eastern limb, which is this limb here. Because remember, what's in the grey is actually on the face of the sun at the moment, facing towards us, and this is what's just going to disappear off the side of the off the western side. So hopefully this looks quite a big spot. We will be watching what's that. There have been some. There was actually a flare. Oh, done it again. Spoiler alert. We have been. There have been some flares just beyond the western limb from 3806. So maybe that will come along and give us a little bit more excitement. Now, as I said,
Ian is asking what the red and green mean here. Can we go back?
Let me just go back. Yeah.
One more.
The red and green. Now, this is a magnetometer reading, and what you've got here is the red. Well, the red and green. What you've got here is all the magnetic. And in fact, it's a good question for what I'm just going to show you. But what it is, that is it's tracing the magnetic field across the actual face of the sun. So the different colors, I can't find my cursor. There it is. You've got a red one there. Now that is definitely the actual active region that they're referring to. And they are red and blue. If you zoom in, then you can actually see red and blue. Now, when we talk about the complexity, and I say you've got 3 letters in there, what it possibly means is the red and blue have become mixed. Something's come up from below, and they're mixed. So you've got blue mixed in with the reds. You'll see them all separate. When that happens, that is when we're going to get some explosive actions. They do not like to be together. Usually you have the blue in a little group, and then you usually have the red. But once they become mixed together, that's when things are going to kick off. But the yellow and green, that is also the magnetic field across the face of the sun. And some of that is negative, and some of that is positive. And this is what I'll explain to you here. So I'm assuming that's what you mean, because this is sort of like what they call a plage here in the actual magnetic. So what I'll do is I'll move on, and then I'll try and explain this to you. This is what is known as a synoptic diagram. And this is from NOAA. Now, twice a day, they produce a map like this. Now, what you've got to remember is this is a two-dimensional image. It looks flat. But of course, what we're actually looking at is half a sphere. And remember, it's only half a sphere. It's if you look at the side of a ball, the center of it is closer to you than what the actual the sides are. So basically, if you hold your hand up, put it sideways. So at the top, you'll be looking basically along the very thin plane of your hand, and that's what you'll be seeing. As you slowly move south, the hand will slowly tilt, and then when you get to the equator, you'll be looking at the back of your hand or the palm of the hand, whichever way you're doing it. And then, of course, as you move south again, it will then turn around and you'll be looking at the other edge of your hand. So you're looking at half a sphere here. So what's in the center, the perspective, is far more accurate than what we've got at the sides. Okay? So remember, you're looking at half a sphere. Now, what we've got here, now this is usually a better way of when you before you look at the sun in different wavelengths, is to look at this because it's basically everything is here. Remember, to see a lot of these things, you've got to change wavelengths and look at different wavelengths. Now, what we've got here, right, let's start at the very top. I hope you can see my cursor. At the top here, we've got a little round puddle. Let's put it that way. That is a coronal hole. As I said, we've got one coronal hole and it's up at the north. The reason I know it's a coronal hole is when you've got the boundary, but then you've got these little hashtags pointing inwards. These hashtags always point inwards, and that will give you a black hole. Now, several different people present these, and some people actually fill this in with black. The number at the top, you see there's this number. The number 75 is the number of the coronal hole. They count these the same as what they do the active regions. So they as they move on, then the next one which will come up, and I'll show you how I know it. Well, it's obvious. The next one will be 76, and if you look down the bottom here, you'll see the next region will be 38, 37, and the next coronal hole will be 76. So that is the number of the hole. Now you've got a minus there. That is the magnetic
Polarity?
what the magnetic polarity is in the actual black hole itself. And the 4 is actually designated. That is really what it means is their confidence that this is the rough shape and they've got the boundaries in the right place. Now, a 4 is a low confidence because if you remember what I said, is that we're looking at half a dome. So this is virtually the perspective we've got of this will be distorted because we're looking at virtually the side of our hand. But that's what that means. So when you see this diagram, a puddle or a round circle with hashtags pointing in, that is a coronal hole. It's coronal hole 75. It's got a negative polarity, and it's they think they're not that confident that they've actually got the right boundary for it. Now the dotted lines, these are what are called neutral boundaries. And what they're doing is they're sketching out, as you can tell, because they come towards the end, they can't really detect where it's going. But what this is marking out boundaries between, if you look here, we've got minus polarity. On the other side, we've got plus polarity. So it's showing you the boundaries, neutral boundaries, where between each polarity on the sun's face. So it's showing you a boundary. So we've got a plus. In some places, we've got a plus. Like all through here, we've got plus. All through here, we got minus. and these are the boundaries that they mark on them. And this all can be seen using the magnetic wavelengths. So this is what this is. A dashed line means this is a neutral boundary. Now, on the neutral boundary, if you remember, we always, when we look on the in the red sun, we see the really dark, what we call filaments. Now, these filaments, 99% of the time, follow these boundaries. They will actually sit across these boundaries, and they can stretch for, you know, almost 2/3 across the way of the actual sun's face. But they will actually sit on these boundaries. You might see some that are marked. They haven't marked any on here, because the person who does it, I think that's CEA or CIA or something like that. Obviously, they don't mark the actual filaments on here, but you will see them sat on these boundary lines, these neutral boundary lines. I've lost my cursor again; it keeps disappearing. Now, excuse me. What we have here, this is actually this person doesn't actually go into much detail. As I said, you got several different people doing it, and they all got their own methods. So what they're saying is now we've got active area 3836, which is this area here. Now, what we've got, as you look here, we've got 4 numbers. You got 40, what looks like a 5, 1, 1. Now, if you look at the top here, you've then got a box, which again has got these 4 numbers. And these are actually, it's telling you the same sort of thing. And I'll tell you what it is. This is for the whole disk. This is saying that they're predicting that actually getting C flares from any of these active regions, there's a 99% chance. Of M-class flares, there's a 40% chance. X, they got 10%, and then a proton storm, they say is 5%. So this is their sort of like prediction of what we've actually got on the sun on here, what we would possibly get. Now, so if you come back here, this is for 3836. There's a 40% chance of a C-class flare. There's a 5% chance of an M-class flare, a 1% chance of a X-class flare, or a 1% of a proton storm. Now, you will never see a 0. Like all good physicists and mathematicians, they don't like putting zeros in anything. They hate zeros. So that's why. So these numbers, if you look at these are telling you what they're predicting for the actual active region, because you've got the number. Then that's telling you there's a 40% chance that you're going to get C-class flares, then 5% that you're going to get M-class, and so on. So, and then, like I said, that is for that active region. This one here, 3834, they say there's a 10% chance of a C flare, and then you've got the ones. As I said, that basically means there's no chance you're going to see an M-class flare or a X-class flare or a proton storm from that area. As I said, they just do not like putting ones in. But that virtually means you're going to see nothing. This area is very, very inactive. But that's what these numbers mean for you. There's also a spot appeared here, which they haven't numbered. Now, what they'll do is if they've got, especially on the western side, if a new area appears, they will not number it. They'll probably mark it and say new, but they won't number it because there's no point in numbering something that's going to disappear off the western limb within a few hours or a few days. So they won't number it. But also, if you see something, a number which is bracketed, it's got brackets, open brackets and closed brackets, that means there was an active region there, and it's actually submerged again. Because remember, these active regions are regions of high magnetic complexity, which have pushed their way up through the sun's surface, And then they'll do whatever they're going to do. They're going to produce flares, or they're going to do CMEs or whatever. And once they finish, they will sink down again. And if a active region is sunk down again, then what they'll do is they'll leave the actual number in there, but they will put it in brackets, and that basically means that it's faded, it's going. And again, on the eastern region, sometimes they'll wait. If something comes around that doesn't look as though it's going to form into anything again, they will not number it. So, and what they do is as I said, they do this twice a day. And this is what they do. They look at H alpha, they look at sunspots, so that's white light, coronal holes, and the magnetic features. And what they do is they write in here what time what images they've actually looked at, so that if any questions are asked, they can go back and say, well, these are the images we looked at, and that's what we've that they can go back and check. Well, this is why we did this. You'll also see where it says east and west on the actual disk. You'll see 29.98, and on the other side you'll see 205.58. That is the lines of longitude. So, wait. No, latitude, sorry. Lines of latitude. So that means that, because remember, they do exactly the same. Remember, Mr. Carrington, he devised a grid method like we have on Earth, where you've got longitude and latitude, and this is what line you've actually got to. So this here, this is line between 205.58, so it's between 205 and 206, and this is the other side. Of course, it'll be the lower number. So that's what we're looking at there. Now at the bottom, as I said, this is where it tells you what the next numbers are, and again, this is all to do with the Carringtons. Of different areas which are coming round of active regions. So this is what we call a synoptic diagram. They'll be changed twice a day. And basically what you normally do is, what the people do is they come to this because everything is marked there. You haven't got to go through all your wavelengths to see the different things. And if you go onto the NOAA site, if you go on the synoptic dashboard, if you scroll down, it will tell you all of this, what each of these symbols mean, what you're looking at as well. So, I mean, there's something here over here. They've circled it. It's got a positive. Obviously, I'm assuming it's a neutral boundary line, and there's just this little spot here, which is a positive in a sea of negative. So that could be something that's either coming up or something that's diminished. So that's a synoptic diagram for you. It's just a little bit of an explanation. I'm sorry I was stammered a bit because I wasn't expecting to do this today. But yeah, that's it for you. So I hope that explains it for you. So if I can get rid of this for you, stop sharing. So if you'd like to talk amongst yourself while I come back. There we go. So I hope that explains to you what you're looking at when you see one of these diagrams. It's one of the first things that you usually go to because it gives you an idea of where things are. And again, Ian, like I was saying, where you saw the yellow and the green, that was what I was saying, between the neutral lines, the positive and the negative fields. That's what they're showing. So that's it. And another thing was with the coronal holes, there's a thing called SNAP, which is spring neutral, spring negative, sorry, autumn positive, and this is for equinoxes. So this is the spring and the autumn equinox. Now, at the different times of the year, depending upon what polarity that coronal hole is, it will give us more activity, more. It will affect the Earth more. If, say, like I say, spring negative, if it's around springtime in the equinox, if it's negative, that's going to give us more activity here on Earth And then in the opposite, in the autumn, if it's a positive coronal hole, that will give us more geomagnetic influence on the Earth itself. So yeah, so just remember SNAP, and then when you look at the around the equinox, if it's like I say, if it's a spring negative, that's going to give more influence to us on the Earth. So I hope that makes sense. I was rambling a bit there because I wasn't expected to do that today. I forgot it was on the end there. So yeah. So any questions? Anyone got any more questions? I was actually wondering about the tables before the diagram, but the explanation was very useful anyway. Oh, thanks for that, Ian. So when you say you're wondering about the colors on the table before, yeah, basically, if I think you're talking, I can't go back now. I've stopped sharing. I know the table you're looking at where you've got the list of the active regions. Most of them were green, and the others were red. Basically, the reason they're green is if they're green, there's less chance of any high activity. But as soon as you get, say, alpha, beta, or alpha, gamma, or anything like that, or alpha, beta, gamma, if you like I said, if you get 3 of them in there, that means the complexities getting mixed up, and there's a big chance that you're going to get an M class. And if you've got 3 numbers, there's a good chance you're going to get an X class. But it's not written in stone, as we've seen. We've seen many of them be mixed, and they produce virtually nothing. Or even some of the green ones have given us a massive CME. Nothing's predictable. But what it is they're detecting a magnetic complexity within the active region, and it's just sort of saying this is how we're going to possibly give us a higher activity. So I hope that explains it. That's what that table was telling you, what the complexity was of each active region. So yeah, there you go. So if nobody's got any questions, I think that's anyone got anything else they would like to say or offer for tonight?
Just one
Failing
thing.
that, sorry.
There's just one thing from me about the launch on Thursday for the Crew 9.
Oh yeah, okay, yeah, that's true.
Are we going to be covering that?
Yeah, well, we can cover it. It's a sensible time for us. I think it's about 7:30, isn't it?
7:05 our time.
7 o'clock in the evening. So yeah, we'll all be able to sit there. We'll be out of our pajamas by then, hopefully. Or we're just getting back in. If some of us go to bed so early, then we've got to think. So yes, on Thursday, isn't it? It's 7 p.m. That'll be 7:05. We'll be hoping to cover the launch of Crew 9. And of course, this is the one where they're sending up only 2 astronauts. I've got no details on it. Have you got any details?
I can get
who they are. It's the Russian.
The American is Haig, I think. I'll have to check on the other one.
Yeah, we've got a cosmonaut and an American. He's actually part of the Space Force team, isn't he? He's
yes, it's true.
Yeah, he's one of the Buzz Lightyears. So he's actually one of the Space Command people. But yeah, they're going up. There's only 2 of them going up, and of course they will be the ones who will be bringing back Sunny and Butch. So yeah, they'll be bringing them back. So keep an eye out. We will endeavour to, as we said, everything can change. It's 7:05, so that's I don't know when did your clocks change, Lou? What date? You're on mute. You're on mute, sir, Lou.
Sorry about that. I said I think it's a week or so, but let me double check.
Right.
Yeah, because it might be. I don't know.
Yeah, I think the only thing they're watching at the moment is weather. So.
Yeah, so just we'll keep a thing. We'll put something up to let everybody know if we're going to be able to cover it, and we'll just keep you notified of what's going on. So so watch the the YouTube and the Facebook channels, and we'll, if we can cover it, we will cover it. But as I said, then that may change due to weather. So I think, Lou, you change at the weekend, so that won't affect you.
Oh, I've just
Always
had an
change on a
update.
Sunday.
I've just had an update, Daz.
Go on then.
It's oh, hang on a second.
November, let's see, that's 2025. Yeah, I guess we should know this, right?
It's actually been moved to Saturday at 18:17 our time. So that's a new update. That's only just happened.
Is that UT or UTC?
It's our time. It's actually the BST.
Right. Okay then. So what was that time?
18:17 on Saturday. So I'm not sure about that.
18:17. So that's our.
Don't think I'll be available now.
Well, I'll be available. 18:17. That's just about 6:15, isn't it?
Yeah.
So that'll be. What would that be? That'll be 15 for you, won't it, Lou? 15, whatever it was. Just gone
right.
3.
No, November 3rd is.
Oh, that's when you're. Oh, so that's not going to affect us this week then, yeah.
November 3rd.
Yeah, so if the launch is at 18, 8:15 here, it'll be 3:15 for you there on Saturday. So yeah, as we said, as I said, everything's can change, and obviously it's been moved to Saturday now. So just keep an eye out in Facebook and in YouTube, and then we'll put out an update when we know what's actually going on. I see Pete's gone, so thanks again, Pete, for joining us. Well, thanks everyone for staying with us. You know, the gremlins are still with us. For some unknown reason, we seem to be plagued with them. We get the exterminator in, and we think we've got them all, but they're hiding in crevices that we didn't think of. So yeah, it's I do apologise, and hopefully Andy will be up and running, and everything will be fine. We look forward to his presentation. Thanks to Michael, Roger, John, Lou, Pete, and myself, of course.
Of course.
I'm sorry about it's been so long since I presented one of these things. I've been so rusty. I couldn't find the controls. Then I got thrown out. I thought, oh, we've lost it. But I noticed it was still running in YouTube, so I thought, oh, that's something. So yeah. But yeah, thank you everyone for joining us. Yeah, that's all right, Andy. Yeah, anytime. But you know, I'll stand in for any time. But yeah, hopefully with a bit more notice. So yeah. So anyway, thank you everyone. We keep an eye out for us to cover the launch on this Saturday. Crew 9 going to the space station to rescue Butch and Sonny, and you know, they won't be bringing them back until is it February? Next February? Yeah. So yeah, it's an interesting scenario. It gives us something to talk about. But we will endeavour to cover it, and as I think just 6:15, you just said. So, but we'll put all the details up so you know when we're actually covering it. Thank you again for staying with us. We hope to see you all again next week. We'll be the same time, same place. Don't forget to look at our library of past shows and our educational shows. They're all on YouTube. And we're always constantly trying to get some new stuff in there. There should be some good stuff coming on very, very soon. All that, in fact, it's all good. But this is even gooderer. This is gooderer. There's a word for you, Lou. Gooderer. So yeah, it's
I'll write that down.
It's 2 R's on the end if you want to talk like Roger. So I'm a farmer. Anyway, thank you again, everybody. And we look forward to everybody. Stay safe. Clear skies to you all, and keep looking up.